Okay, alright, so you'll remember, people, that last lesson we were looking into geometric sequences, so your multiplication of your common ratios and all that, not adding, subtracting, it's multiplication, and also division, but more so multiplication, and how we've got recurrent relations for a geometric. So a recurrence relation, if you forgot, basically is like the instructions or the rule on how to get the next term or how to generate a sequence. Okay, normally you will use your recurrence relations to draw your sequences, or to actually list out your sequences. Okay, so keep that in mind. This guy here is a recurrence relation. Tells you your first term, okay, and it tells you how to get the next term. Just that. Just ignore this one. This is 8G. Okay, let me rewrite this. So for a recurrence relation here, you've got your first term, good, but then you've also got Tn plus 1 is equal to current term times 2. So it's saying times by 2 to get the next number. That's all it's saying. And we've generated the terms. And in terms of generating the term, you have to show you're working out. People don't like this, but you have to show it. Even though it looks pointless and really tedious, you have to show how you got each term. So term 1 is there. It already tells us what's term 1. Term 2 is here. So to get term 2, it's current term times 2. So it's going to be T1 times 2, which is 5 times 2, which is 10. And then you just keep repeating the sequence till you get however many terms you want. Keep in mind geometric sequences, okay, they are exponential. It's not a straight line. Okay, it's going to be a curve. Whereas arithmetic, it's a straight line. Ooh, one more thing. Nth term rule right here. The nth term rule tells you the value of any term that you want. So if you're looking for the 100th term, 50th term, 10 millionth term, use this rule. Okay, because it's going to take you too long to do it by hand. Use the actual rule to find any term that you're after. Okay. Next part. So let's get into 8H. So this one is a little bit trickier because instead of using some of the terms that we've used, like T1, instead of using T1, we'll be using other ones. Okay. And generally, this question comes along when you're doing application style questions. Okay, so just keep that in mind. Let's read this real quick. Linear growth and decay is found in the world around us. Linear growth or decay occurs when a quantity increases or decreases by the same amounts at regular intervals. Okay, so in this case, linear, okay, just means it's the same amount each time. Yeah, so it's going to be a straight line. So think of linear as being related to arithmetic sequences. Okay, so when you see the word linear, it's going to be some sort of arithmetic sequence. Okay, and growth and decay, we all know what that means. Yeah, growth means it's going up, decay means it's going down. Okay, so examples of this, and you'll see this a lot, is when you see the word flat rate or straight line depreciation. That's all linear decay. Okay, I know these words are probably a bit unfamiliar to you, but just look out for them when you read questions. Flat rate, straight line. Okay, that all means linear. So when it's linear, then think arithmetic. Okay, here's an example that we have where I said there's a slight difference. So you'll remember that generally, instead of V0, we use T1. Okay, but now, when it comes to linear growth and decay, we're going to use what we call V0, or the starting term. Now, this is different to the first term. Okay, different to the first term. Starting term is not the same as your first term. You got to remember that. Okay, here's a recurrence relation of it. Yeah, right here. Now, according to the recurrence relation, the starting term is 2000. Okay, and to get the next term, you're just adding 150. Okay, but if you read the question, where did they get 150 from? I see the number 2000, but where did they get 150 from? Okay, well, you have to read the question. Okay, it says here, the following recurrence relation can be used to model a simple interest. There's a key word there. When you see the word simple interest, arithmetic sequence. Okay, it's an arithmetic sequence. Okay, investment of $2,000. I'm going to highlight that too because that's important information. Paying at a rate of 7.5% per annum. Now you might think, oh, there's percentages here. This is probably going to be geometric. It's not, okay, because of this word, simple interest. You got to keep that in mind. Simple interest means arithmetic, or it's generally adding or subtracting by the same amount. Now, where they got this from, 150, is if you read the information here, paying at an interest rate of 7.5% per annum. That means that every year you're getting 7.5% of this guy. That's all that's saying. Okay, paying 7.5% of the starting amount. So that means this 150 came from this percentage. Now, how do you get that? Well, 7.5% of 2,000. Okay, do we know how to work out percentages of numbers, people? Yeah, what do we do? Tell me.
0.75 times 2,000.
Okay, where'd you get 0.75, Keaton?
I divided by 10.
By 10? Are you sure it's 10? It should be 100.
100.
Yep, correct. Then times 2,000. And that will give you 150. 150, which is this. Okay, so that's the, you can think of it as the common ratio, common difference, what you're adding by each time. Okay, so with these questions, what you need to do is find, actually I'll make this more obvious. For this, you need to find percentage of starting amount, or you could call it the principal, which is what some people will call it. Okay, so that means when you get a question like this, you're just finding a percentage of the principal to get this guy, because no one you won't be able to find this unless you read the question. All right, so let's keep going. Use a recurrence relation to find the value of the investment after 1, 2, and 3 years. So it's already given us the recurrence, so that's fine. And the reason why I say that V0 is different to the starting term is because you can see here, the starting term is 2,000, right? But the first term is the first year. Okay, second term is the second year, third term is the third year. So V1 is not actually this. Okay, keep that in mind. It's not the same. So let's start with just writing V0 first. So V0, 2,000. Okay, let's start with that. So that means V1, looking at my recurrence relation, is going to be Vn plus 150. Okay, so it's the current term plus 150. So that means it's going to be V1 equals 2,000, or I'd write V0 plus 150. You don't have to write this step. You can go straight to the 2,000 if you wanted to, but I'll leave that in there. Okay, just for the sake of having it. So it's going to be 2,000 plus 150. Therefore, V1 is equal to 2150. V2 is going to be Vn, or actually I don't even need to write Vn, I'll just go V1 plus 150. Okay, I'll just skip that step. So V2 would be 2150 plus 150. Therefore V2 is equal to 2300. And then you keep repeating until you get to the third term, because it says the first 3 years. So you must show you're working out like this. Okay, so it's basically the same thing as what we've been doing, except that now this time, instead of writing the first term, you're just going to start at the starting term. Okay, so there's your first 3 terms there. Oh, okay. I should have written it here. Sorry, should have just done it down there. That's okay. Okay, part B. The question there is, when will the investment reach 2750 in value? So I'll do that. Okay, I'll just do that here. Let's do it in this box, guys. Sorry.
Year 5.
Year 5, essentially, yeah. But you need to show. Actually, you don't necessarily need to show working out for this type of question. But every now and then, it'll want you to use your calculator. Okay. And in terms of doing that, we'll look at that later on. But you can keep doing this if you like. Okay, or you can use your calculator. So if you get your calculator out, right, and you start with 2,000, so that's the starting term. And then to get the next term, remember it was plus 150. So that's year 1, 2, 3, 4, 5. And we're asking for what year will it reach 2750. So basically at the 5th year. It will reach 2750. Cool, easy. All right, next one. This is going to be the same thing, but looking at the words this time, instead of increasing, okay, it's going to be depreciation, so it's going down. Okay, so read the question. The following current relation can be used to model a flat rate depreciation, I should highlight that too, of a car purchased for. So this tells you, if a question asks you, what is the initial value of something, you can look at a keyword like this, purchased for. That's how much it started with. Okay, and it's depreciating as well at a rate, another word, flat rate of 10% per year. So I like to highlight the key words here so that we know what we're working with. I probably don't need that because there's already flat rate there. Okay, so keywords there, you've got flat rate, it's depreciating, so it's going down, 10% per year, so it's going to be 10% of this amount here, the 18,500. Oops. Okay, 20%, 10% of that guy. So to work that out, let's work it out. Actually, let me just show you guys quickly how you work out the percentage of that again. So it's going to be 10% of 18,500. So how did they get this? It's going to be 10% of 18,500. Yeah, so 10 over 100 times 18,500, which equals 1850. So that's how they got that. Remember, it's depreciating, so it's going down. Okay, so let's answer the question. In the recurrence relation, using the recurrence, find the value after 1, 2, and 3. So let's work that out. Always start with V0. Remember, that's not the same as first term. Okay, it's the starting term. Alright, so V1. Looking at your recurrence relation, should be current term, so V0, take away 1,850. Okay, so that means V1 is equal to 18,500, take away 1,850. And I am not smart enough to do it in my head, or I just can't be bothered. So, and I might actually do it here too, because we're going to use the calculator again anyway. So 18,500. So always start with the starting term. Okay, and then press enter, so you've got it. And then you know that the next term is going to be minus 1850. So that means 1,850. Term 2 is 16,650. Sorry, V1, 16,650. Okay, and we keep repeating it. So number 2 is going to be V1, take away 1,850. So it's going to be 16,650, take away 1,850. V1,
18,650.
Yeah, 18,650. Oh, sorry, 16,650. Sorry for the crappy writing. And we keep repeating it. So year 2 would be 14,800. So V2, 14,800. Hope you guys are following me so far, and that I'm not going too quick. But V3 would be V2, take away 1850 again. So it just repeats. And V3 is equal to, pressing enter here, 12,950. Easy. Alright, nice and easy. So you have to show you're working out like this, otherwise you will not get full marks. Okay, so how long will it take for this to depreciate to 0? The value to reach 0. So the next part here, how long will it take for the car to reach 0? So you can use your calc for this, that's totally fine. We are up to, so that's 0, 1, 2, 3. So if I just keep pressing enter, 4, 5, 6, 7, 8, 9, 10. Year 10, it'll reach 0.
Can you explain how to do that thing again, like how it repeats itself?
Yep. Okay, I'll do that now. So to get to this point, you always have to start off by writing your starting term. So starting term was 18,500, right? And then you press enter. And then from there, you got to figure out, okay, is it minusing, is it adding, is it subtracting, is it multiplying? Well, you look at your recurrence relation, it says it's minusing 1850 each time. So you just literally write on your CAS, press the minus button, this one here, and then 1850. And then you just keep pressing enter. So when you press enter once, that's term 1. Enter again, term 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. Easy. Okay, so on the 10th year. Just keep this in mind. In year 11, we're not too strict with you writing it in sentences, but in year 12, because we don't mark your exams, they would want you to write your answer as a sentence. Okay, so please do it now. Just start doing it now, so you don't have to, worry about it. Okay, does that make sense so far? So that's pretty straightforward. Linear decay and growth is that for your recurrence relations. Yeah. So you've got your recurrence relation. It tells you how to get the next term. But now we also have a linear growth and decay nth term rule. Okay, so just really quickly, I would probably have you guys write this in the second page of your notes. Okay, so this here, okay, and this here are the new or different types of recurrence relation and nth terms when using V0. That's the main thing to look out for, the V0. Okay, when you're using V0, but when you use T1 or the first term, you can use the original ones. But when you're using starting term, you have to use these ones. Now, you see the difference here is that when it comes to having a recurrence relation with the first term, okay, obviously uses term 1. It's not that much different, okay, but the way we find the common difference is a bit different, yeah, for these questions. So remember, with the common difference for these questions, I'll quickly just go back up. We use this. We had to find a percentage of an item, okay? So just watch out for that because it's slightly different to what we did before. Here, you can see that the common difference is basically the thing that you're adding or subtracting by. Now, that's for the recurrence relation. I'll write that here. If you put this in your second page of your notes, I'll write down, this is what you should put. And, oops. When using V0. Okay, so just keep that in mind. But then what changes here is if you look at the this current rule, I'll leave that here, sorry. So if you look at the old nth term rule, does anyone remember the old nth term rule? Tn equals A plus n minus 1 times D. Now, you can see that this one is actually quite similar, but what's different now is that there's no more minus 1, okay? And instead of using first term, we just use V0. That's all that's changed. So it's the same thing. It's just that because you have V0 now, you don't need to minus, okay? You don't need to actually minus anything. Okay, there's no need for that minus 1 anymore. Oops. Okay, that's not needed anymore. Okay, so this is the old one. Still useful if you're using first term. But when you have starting term, okay, it's slightly different. Okay, so use this as a nth term when using, oops. So when you're using V0, use this as an nth term. And we'll look into some more questions for that. And it's the same thing. So that's for growth. And then if it's for decay or when it's going down, just watch out, okay, because instead of plus, okay, so you see there's plus there, it's going to be minus, okay, because it has to depreciate, has to go down. So I would put this as well in your notes for the second page. Okay, this here. And this one. Very important that you know them. Okay, these ones. So this is going to be recurrence when using V0. But just keep in mind that this one has a depreciating. Okay, and this is the nth term rule when using V0. But again, it's for depreciating, so it's going down. Okay, let's keep going. That'll be all in there, guys. So, how much left? Okay, there's a little bit more, then we're done. All right, let's look at this example. The following recurrence relation can be used to model a simple interest. Again, it's going to be linear. Simple interest investment of $4,000. Okay, another keyword there. Paying at a rate of 6.5% per year. All right, keywords there to look out for. It's going to be simple interest. Your starting term is 4,000 and it's 6.5% of that amount. So the way they got the 260 was basically 6.5% of the 4,000. Okay, so if you forgot how to do that, it's just basically 6.5 divided by 100 times 4,000. And that gave them this amount here. Okay, that 260. That's where they got that 260 from. Where did my pen go? Okay. Cool. All right. So, question 1. How much interest is added to the investment each year? That's really easy. How much is it adding by each year? Easy. 260. Okay, so it's saying what's the common difference? How much is it adding each year? Part 2, use the rule to find the investment after 15 years. Now, that's a lot, isn't it? And you're not going to do it by hand. It's too much. So if you're trying to find something that's of high term, what should you use? Use the nth term rule. So we have the new nth term rules here when using V0. I'll write it down here again. So the rule for the nth term rule is going to be Vn equals V0 plus n times d. Or I'll use the big D. Okay, this is the nth term rule where you use V0. Okay, so according to this, we're looking for the 15th year. Okay, and I already know that my common difference is 260. Okay, and my starting term is 4,000. Okay, so just put those numbers in your calculator or in your formula. So V10 would be 4,000 plus, I'm looking for the 15th year, times 260. Okay, so that means the 10th year, 4,000 plus 15 times 260. So it's 7,900. Straightforward, nice and easy. Part 3. Use a rule to find when the value of the investment first exceeds $10,000. Now this one is a little bit tricky, okay? Because it says to use the rule and not use your calculator recursively, okay? Now, this one will take a little bit of work to get used to, but you've probably all done a little bit of it before, okay? So using the rule, which is your nth term rule, this guy, the Vn. So remember the rule was this, Vn equals V0 plus n times d. So it's asking us in this question, when will it first exceed $10,000? So basically what it's saying is, what is the year of when you have more than $10,000? So according to this, n should represent the year. So if we're going for $10,000, it does say exceeds. Now, what you'll find in Year 12 is they trick you a little bit with this. Because it says exceeds, you have to go above $10,000. So what's the next number above $10,000? 10,001. So you got to tell me at what point does it reach 10,001. So it's going to be 10,001 equals the starting amount, which is 4,000, plus n, which I am looking for, times the common difference of 260. Now, what do we think we should do with this using our CAS? Use a solve function. just use your solve. So on my CAS, I'm going to go solve, and then this, and then comma, n. All it is. That means the number of years will be equal to, so we're going to go solve 10,001, because it says exceeds 10,000. So that's actually a year 12 question. 4,000 plus n, which I'm looking for, times 260, comma n. So when will it reach over 10,000? Okay, if you get that, just press Control Enter. So 23, basically on the 23rd year. Okay, on the 23rd, but I would actually probably round this to 24, because at 23.08, and this is the tricky thing, is when it actually reaches $10,001. But you want to go above that. And generally with years, you're not going to be, it's 23.08 years. Okay, round this to 24. Okay, because it's at what year will it go above the 10,000? So at 24 years, it'll definitely be above the 10,000. Do you have your hand up? Okay, I know that's a little bit, a little bit tricky to understand, but you'll get used to it as you do more of these questions. So I'm just gonna write. The calculator said 23.08, but round it to 24th year.
No, wouldn't it just be like 23.1?
So if it's 23.1, they would want you to answer in whole years. Generally with these questions.
So it'd just be 23 because that's.
Well, if you leave it at 23, it'd be like $9,999 or something. Okay, I'll show you. So if I left it at 10,000, for example, actually, if I left this at like 10,000, so the answer will be like 22 point something, I reckon, or 23.07. Yeah, so you want to go 24 basically, because at 23, if you write 23 on the SAC, they'll just say, oh, this guy didn't fully work it out all the way to over 10,000. Okay, because you're stopping at 23 there. It's a really tricky question, I think. It's just one of those ones where you got to keep doing again and again until you get used to actually rounding it properly. Oops, wrong one. Okay. All right. Does that make sense so far, guys? I'm gonna just pause that there.